Now, to chair this session, I would like to welcome my colleague, Dr. Syed Imran Shafiq Sahab.
Dear participants, a very good morning to you all. My name is Dr. Syed Imran Shafiq. I am Associate Professor in Mechanical Engineering section of University Polytechnic. And I welcome you all in the first session of this Atal AICT FDP on Advanced MATLAB for Scientific Computing. To set the ball rolling for this FDP, the organizers have purposefully selected the first lecture as fundamentals of MATLAB. Once we know the fundamentals, after that we can dive into the advances of MATLAB. So to deliver this lecture, I would like to invite my young and dynamic colleague, Mr. Atib. And let me give you a brief profile of Mr. Atib. Atib Ahmed Khan completed his Bachelor's of Technology and Master's of Technology degree from Aligarh Muslim University at the Department of Mechanical Engineering. In 2013, he graduated with first class honors degree in mechanical engineering. And in 2015, Atib Ahmed Khan graduated with first class honors degree in machine design specialization and was awarded 2 gold medals for securing the first position in the university. In 2015, he went to Berlin to work with Professor Christina Wollmeck at the Technical University of Berlin on the topic of analytical modeling of mechanical and buckling behavior of functional graded sandwich structures. In 2016, he joined the Department of Mechanical Engineering at the Aligarh Muslim University as assistant professor. He has many publications in reputed journals with published patents. So I'm sure that he will be giving a very fruitful lecture on the fundamentals of MATLAB. With that, I hand over to Mr. Atib. Please carry on, sir.
Thank you, Dr. Imran Shafiq, for such an elaborate introduction. Thank you, sir. And thank you, Dr. Danish, coordinator, and Dr. Afsar Hussain, co-coordinator of this FDP, who gave me this opportunity to speak before such a learned audience. And good morning, dear participants. My name is Atib Ahmed Khan. I am assistant professor in the Department of Mechanical Engineering at Aligarh Muslim University. And my research area includes the modeling and analysis of your composite structures, your functionally graded structures, including the sandwich structures, and impact mechanics. So I have been using MATLAB for the numerical analysis of such types of problems since a long time. And I hope I can deliver you some of the information which will be beneficial for you. So before barging into the fundamentals of MATLAB, let's see what was the main purpose of inventing this MATLAB. Why was it invented? Who invented this? And how the capabilities of MATLAB kept on increasing year after year. So let me share my screen first. Yeah, so I hope my screen is visible to all of you.
Yes, your screen is visible.
Okay, so I'll be starting with the evolution of MATLAB, how basically this MATLAB evolved over the years. And then I'll be taking the fundamentals of MATLAB. I'll be familiarizing you with the basic, with the basic structure of the MATLAB. And then we will see how MATLAB, why we call MATLAB as a matrix laboratory, and how the basic building block of MATLAB is still a matrix. but we can do a lot many more things than it was there in the first version of MATLAB. After that, I'll take the visualization part where I'll be taking the 2D plots, the surface plots and the 3D plots. And towards the end of this lecture, I'll be discussing the how to make a user-defined function. Basically, there are there are a large number of already predefined functions in MATLAB, which I'll be taking in this lecture. And then there is a method by which you can make your own function. You can make a library of your own functions, and you can call it whenever and wherever you like in your main program. So that is very beneficial. For example, I'll tell you, if you want to calculate, just a small example, if you want to calculate the hypotenuse of a right angle triangle, so there isn't any function in the MATLAB or a predefined function in the MATLAB, but you can basically define your own function in order for it to calculate the hypotenuse of a right angle triangle. So this was just a small example of the use of the user-defined function, but the possibilities are endless, and it is being used widely by the programmers. So let's just a second. Yeah, let's start with the evolution of MATLAB. So yeah, so this gentleman on my screen is Dr. Cleve Moeller. So he's a mathematician and a computer programmer, and he did his bachelor's from Caltech University and his PhD from Stanford University. And during his PhD, he came with this. Basically, not during this PhD, from his PhD thesis, he got this idea to develop this a software, which we today known as MATLAB. And when he's basically a mathematics professor at University of New Mexico. When he started to develop this MATLAB, and along with his supervisor, George Forsyth, in the year 1967, he developed the first version of the MATLAB. And the reason for him to develop the MATLAB was just as a hobby and to help his students, who was again a mathematics student, to solve the large matrices. So in the beginning, as you all know, in today's MATLAB, we have a lot many toolboxes. We have a graphics interface. We can solve ODEs, PDEs. We can solve Fourier transformation. But initially, it was just made to basically just to solve the matrices and to do the basic functions with the matrices. So the MATLAB was invented by him along with his PhD guide, Dr. George, just as a hobby and just to help his students to make the calculations easy. Now, the software basically was introduced to the public in 1979 at the Naval Postgraduate Institute in California. And the early versions or the starting version of the MATLAB was having only 71 pre-built functions. Now we have a lot of functions, but at the starting it was having only 71 pre-built functions. And what Dr. what the inventors of this MATLAB has done, that wherever they go, wherever they have been invited for the lectures, they take a copy of MATLAB and they distribute that copy into to the university as well as to the students. Initially, it was free, so they keep on distributing the copies to the students and to the universities. And that's how it gained popularity among the mathematics department of the various universities. So till now, the MATLAB was free. Nobody charged for the MATLAB. But then this guy came, which again you can see in this pic. The name of this person is Dr. John N. Little, and presently, I mean, he was the president and co-founder of the MathWorks. So he basically identified the potential of the MATLAB and decided to rewrite the MATLAB along with obviously Dr. Cleve to write the MATLAB in C language. So Dr. John Little along with Dr. Cleve and Dr. Steve Bangred reprogrammed the whole of the MATLAB, which was developed initially by Dr. Cleve, and they have written the MATLAB in C, and they introduced a lot many toolboxes and the potential to solve the ODs and the PDs in the MATLAB, and then basically they commercialized it. Okay, they commercialized it, and MATLAB was first released as a commercial product in 1984 at the Automatic Control Conference in Las Vegas, and MathWorks Inclusive was founded to develop the software, and the MATLAB programming language was released. So this was the timeline of the MATLAB. It was initially developed as a hobby just to support the students, but it later on got commercialized, and this idea basically was basically came into the time where the mainframe computers were replaced by the IBM desktops. So at that time, this MATLAB came into existence, and these guys, Dr. John and Little, was the main person who basically the main mind behind commercializing this software. So by the end of 1980s, several hundred copies of MATLAB has been sold to the universities, and it got very popular. Basically, when it was commercialized, the first 10 copies was bought by Massachusetts Institute of Technology, MIT. And then later on, later in the 1980s, near to the 1990s, it got very popular with the other famous universities, and now it is very popular among the engineers and the scientists because it makes the programming very easy. Those who have already worked with C or C++ or Fortran will appreciate that how easy it is to program in a MATLAB. Yes, I understand that it takes basically the runtime for the MATLAB is more when compared to the Fortran, but we have optimization techniques for that in MATLAB. So if we optimize our program properly, it will surely be at par with the Fortran, if not better than Fortran in terms of runtime. But definitely the programming time or the time required to write the code in MATLAB is definitely very, very less when compared to the other types of languages as C, C++, or Fortran. Now, regarding the logo of the MATLAB, this is a page from Dr. Cleve's PhD thesis. As you can see at the bottom, the page number is also written 124. So in this figure which he has drawn, this is basically he has solved a differential equation in an L-shaped membrane. And this became the first logo of this figure over here, became the first logo of your MATLAB. Okay, so in 1964, when it was introduced, this was the first logo of the MATLAB. This is a 2D plot of an L-shaped membrane. Then in 1968, basically some student of Dr. Cleve, I cannot recall the name of that student right now. So as a student project, he basically plotted the same problem in 3D, and in 1968, the logo changed to this. And in 1985, the first MathWorks documentation and the first surface plot was made, and the logo changed to this one, the third logo, which was in 1985. And then towards the 1990s or early 1990s, again, the logo changed. But the only difference between the 1985 logo and the 1990 logo was that the 1990 logo was printed with the help of a laser printer. So the resolution of that logo was better. Then in 1992, the colors was introduced into the same L-shaped problem, surface plot of an L-shaped membrane. And then towards 1994, it improved in terms of resolution and in terms of colors. And in towards 1996, we got the final logo of MATLAB, which we today have. Although there were some small alteration in this 1996 logo also, but as of now, we have a somewhat similar logo as it was developed in 1996. So it is basically the idea of the logo is also from the PhD thesis of Dr. Cleve, where he plotted a 2D graph of an L-shaped membrane, and which basically keep on improving the quality of the graph, and from the 2D it was converted into a surface plot and then to a solid 3D plot. So this was all about the evolution of the MATLAB, how it evolved, how basically it was invented. Yeah, and in 2004, MATLAB also introduced the capability of parallel programming. Before 2004, it was not present in MATLAB, but in 2004, the capabilities of parallel programming is also introduced. And in 2016, near about 2016, a live editor was introduced in the MATLAB, and it is very useful because I mean, it is a great tool. If some, I mean, what happens in live editor is that you can it becomes as a document. You can write your code in it. You can embed different figures in that. You can even embed your results in that. You can make a result table. You can extract directly a result table from the written code, and then you can print that document as a PDF or a doc file. So this capability of MATLAB was introduced in around 2016. However, let's move on to the fundamentals of this MATLAB. MATLAB, the full form of MATLAB is Matrix Laboratory, and it is a command-driven software, which I already told you was originally developed for matrix operation and for linear algebra computation. The first capability of MATLAB when it was introduced back in 1980s was only to solve the linear algebra problem of large matrices. Now, when it became commercialized, it was obviously developed by MathWorks, and it offers a great programming environment. And as I told you in the beginning of the lecture, that it has a lot many built-in functions. You need not to solve the ODs using different numerical techniques. There is a built-in function in the MATLAB to solve the ODs, the PDs, and to integrate the function, the image processing, optimization. There are many tools like ANN, curve fitting tools. And yes, in MATLAB, you can do symbolic programming, okay, which you cannot do in C or in C++ or in Fortran. These three are not capable of symbolic programming. But in MATLAB, you can easily do symbolic programming because the MATLAB identifies a variable which hasn't been assigned any value. Okay, that's why you can do a symbolic programming in this MATLAB. Okay, so starting with the basics, the MATLAB has a command window, a workspace window, and the history of the history window where the commands are shown. Now, the best thing to start with MATLAB is to use the first command to use with MATLAB is your help command, HELP. So if you are not sure about any command, for example, there is a command DIFF. Okay, this is to differentiate equation. So if you are not sure about this command, what you can do, you can type help in MATLAB, HELP. Then somebody is asking a question. What is the full form of? I could not get the question. If anybody can tell me. Anyways, So what you can do with help is HELP and then space and then DIFF. This is to differentiate any equation. And you can, if you are confused with what we can do with this help command, then you can type help space help in order to get the information about the help command in MATLAB. So this is the basic introduction window of the MATLAB, where this area is known as command window, where we are going to input our commands. As I told you that MATLAB is a command-driven program software. This area over here shows you the current directory. This is your workspace, and this is your command history. Over here, you can see what are the commands which you have already entered. So, I mean, this is the good time to show you the MATLAB window. So as I told you, this is the command window. You can type help, which is very useful, and then help again. Okay, so this will tell you everything about the help command, what help command can do. And I was telling you that there is a command which is DIFF to differentiate the any equation. So you can also type in over here help and then DIFF, and it will tell you everything differentiation or DIFF command can do. Okay, so this was all about the help command, and this is your command window. This over here is showing you the current folder which I am in. So I have already some programs over here, a very small programs of 4, 5, or maximum 10 lines over here. Okay, and this is your workspace. Workspace basically shows all the stored variables. For example, if I assign a variable to this thing, for example, x equal to 10. Okay, so I have assigned a value of 10 to a variable x. So now you can see that the workspace is showing me this x variable. Similarly, if I assign another variable y equal to, in single quotes, my name Atif. Okay, so this is showing you the type of the variable and then what is stored in the variable. If you are not sure about the class of the variable, you can always type a command class and then the variable name, for example, y, sorry, and then the variable name y, and it will show you that this variable y is basically a character type. Characters are stored in this variable y. Now over here you can see that there is another variable which is answer. So answer by default is a variable of the MATLAB, where if you are computing anything and you are not storing it in any variable, it will get stored in answer. For example, if I want to calculate what is 5 plus 4, so I haven't stored this value 5 plus 4 in any variable. So by default, it will get stored in the default variable of MATLAB, which is answer. Okay, now if I want to store this this value in some variable, for example, y equal to 5 plus 4. Now this time it will be stored in the variable y. Okay. Now in order to clear the command window, what you have to do, you have to type CLC, and your command window, all the previous commands will be cleared. And in order to clear the workspace or the variables, what you can do, you have to type clear. You have to type clear and then the name of the variable, for example, x. Okay, so this will, oh, sorry, yeah, clear. So this will clear the variable x from my workspace. As you can see, the variable x is cleared from here. Similarly, if I again store some variable x equal to 5. Okay, so you can see again this variable is stored in the workspace. Now, if I want to clear it, suppose now this time I want to clear the variable y. So if I type clear y, you can see from the workspace, the variable y is cleared. Now nothing is stored in y variable. Now if you type y, it will say that unrecognized function or variable, because nothing has been stored in this variable y, and MATLAB doesn't know what y is. Now, suppose you have 10 or 15 or more large number of variables stored, and you want to clear all the variables. So what you have to do, you just have to type clear or clear all in order to clear all the variables. Now you can see that no variable is stored in this MATLAB. Okay, now coming back to the presentation. So I hope this thing is clear. What is command window, what is current directory, and what is your workspace. Now moving on, I have already told you what this help command can do. So whatever command you are not sure about that what it can do, you just have to type help and then space and then the command name. So it will give you all the information about that command. And if you are not sure about what help command can do, you can type help and then space help like this over here to, as I showed you, to get the information about this help command. Now you must have seen that I have directly, this is basically for those who have already worked with C or C++ or Fortran, where you have to tell the program that what type of variable you are going to declare. Okay, you cannot just assign a value to any variable, so and it doesn't take, it takes automatically the value of that variable in these platforms. Whereas in MATLAB, you can just directly assign the values to a variable, and it will automatically take the variable type of depending upon the input of the user. For example, I have shown you in this MATLAB where I have written x equal to, just a sec, yeah, x equal to 5 or 50. So I haven't told MATLAB that x is going to be an integer type variable. What MATLAB has directly identified that since the user has input a value 50, so this x is going to be a basically an integer type variable. Similarly, if I take another variable z equal to, again, if I want to enter some characters, suppose I say this time I'm going to enter Khan. Okay, so this time again, I haven't told MATLAB that Z is going to be a character type variable. Just by my input, so, just by the input of the user, MATLAB has identified that this variable Z is to be of character type. So this is very easy in MATLAB. You need not to predefine any variable. Just by the input of the user, MATLAB identifies that what type of character user want to use. Okay. Now coming to the CLC command. CLC command is to clear the command window, as I have already shown you when we were on the MATLAB. And clear all or just clear. You can use just clear also to clear all the variables in the MATLAB history, okay, or in the MATLAB memory. So, and if you want to clear some particular command, what you have to do, you have to write clear and then the name of the variable. And if there are more than variables, then the variables can be separated with the help of a comma. Okay, so this is how you are going to delete the already pre-stored variables. Now, an important thing to note here is that your MATLAB is case sensitive. So clear with small alphabets and clear with capital alphabets are two different commands for, or two different variables for MATLAB. So you have to be very specific with the case sensitivity of MATLAB. If you have assigned any variable, say XYZ with small alphabets, then you cannot call XYZ with capital alphabets, because MATLAB will not know what is capital XYZ until and unless you are going to tell MATLAB what it is. So it is It is case sensitive, and you have to be careful while programming. Now, you can give any type of variable name in the MATLAB, but there are some restrictions on giving the variable name. As you have seen that till now I have used X, Y, and Z, but that is not the case. You can take any variables, but there are some restrictions, and those restrictions are a variable name must start with a letter. Okay, means it should start with an alphabet. It cannot start with a number, and it may contain only letters, digits, and underscore. Okay, no special characters except for underscore. You cannot enter a star, or you cannot enter a dollar sign or a rupee sign for a variable name. So variable name can comprise of only three things: alphabet, a digit, and an underscore. And it has to start, a variable has to start with a alphabet. And as I already told you that it is case sensitive. So one written over here and one written over here are two different variables for MATLAB. All the variables which are stored in MATLAB are basically stored in the form of matrices. Whether we are going to enter a 3 by 3 matrix or n by n matrix, or simply a number which has been stored in a variable, which is, for example, 5, 50, 500, then also it will be stored in a matrix of 1 by 1. Now, as I told you that you can directly assign the values to the variable. For example, you have a variable which the name of the variable should be according to these 3 points, and you can directly use the assignment operator, which is equal to, and then the number. Now here you can see that there is a semicolon at the end of the command. Now the semicolon is important if you are going to write a large program, because what this semicolon does, basically it is going, if you have suppose n number of lines in your program, and after every line if you are going to use this semicolon, so what it is going to do, it is going to execute that line, but it will not be shown on the MATLAB screen. So what happens when you write a proper program in order to calculate anything? For example, I use it for numerical analysis of different structures of different materials. So at every point, I don't need to get the answer, because there are many variables which is to be calculated in order to finally get the deflection of that structure with some applied load. So if I don't use this semicolon, so after every execution, it will show me some output. And if I don't use this semicolon, it will take a large memory in my system, and obviously it will take a much longer time to execute the complete program. So usually it is a habit of to use this semicolon after every line, until and unless we really want that line to show the, or that code to show the output. So usually we only use the informations or the parameters which we want to extract. We don't use the semicolon after that command, but in general, we always use semicolon. So the idea is that if you are going to use semicolon after any command, it is going to execute that command, but it is not going to show you on the show the output of that command. Okay, now moving further. Yeah, so till now you know that there are 3 rules according to which you have to decide the name of the variables. But then there are some special variables already pre-assigned by the MATLAB, which you cannot use, as I have already shown you that ANS, which is the short form of answer. So ANS is a default variable for MATLAB to show the results or the results of the command which you have already entered. Now, MATLAB is going to use this default variable only in the case where you haven't pre-assigned the value of the operation to some command. Okay, this thing I have already shown you, that when MATLAB is going to use this variable and when it is not going to use this variable. Now, the next type of spatial variable or the pre-assigned variable is pi. Now, the value of pi is already, 20, this 3.141 dot dot dot. Then the third one is EPS, which is a short form for epsilon, and the value of the epsilon is you can see on the screen. The next pre-assigned variable is INF with capital I and INF with small I. This is for infinity. Now, if you know, if you are going to divide any number with 0, it will give you an answer as INF. Another reason for giving an answer in infinity for MATLAB is that there is a limit. Uh, I mean, there is a limit for MATLAB to just a second. Yeah, there is a limit for MATLAB. There is a number, the highest number in the MATLAB which can be stored, and the minimum number which can be stored. So if you are going to use any number higher than that number, then it will show you the result infinity. Or if you are going to use the number lesser than the minimum limit of the MATLAB, then also it is going to show you the result infinity. Okay. So here I have used a command real max. So real max is showing me a number 1.7977 into 10 raised to the power 308. So this is the maximum limit for the MATLAB. If I'm going to use, or if I try to multiply this number with infinity, sorry, with 10. Okay, what I have done, I have I'm basically going to multiply the maximum number which MATLAB can understand with 10. Now you can see that the result is infinity. Okay, this is because the maximum number which MATLAB understand is this one. And similarly, you can find the minimum number by this command real min. So this is the minimum number which MATLAB can understand. Below this number, you are going to get again infinity or negative infinity. So I hope the use of infinity is clear to you. Now, not a number. Okay, not a number is basically when you are going to use some absurd expression. Then MATLAB is going to show you not a number with capital N on both sides and with small n a n. These both the variables are recognized by MATLAB as predefined variables, and you cannot assign the values to this variable. Now the next one is I and J. I and J are basically used in the complex number, in order to define a complex number, and the value of this is under root -1. So this is again a predefined variable, and you cannot use it in order to define any value. Now there are some other types of function also, for example, clock, date, and calendar. Let's move on to this MATLAB again, and I'll show you the use of this. Yeah, so clock basically shows you the clock of the system on which I'm going to use the MATLAB. Now this format is not very much familiar to you. I'm going to use another command fix, which I'm going to explain later on this presentation, what is the use of fix. But for now, you can take my word that fix is some command which is doing something. Okay, so now you can see that this fix clock command is showing me, first of all, the year in which we are, the year of the system, and then the month of the system, the date of today's date, that is 13/9/2021, then the time in hours, minutes, and then seconds. Okay, so this is how you are going to use the clock. The next one is calendar. So calendar basically shows you the calendar of the present month. Now suppose if you want to see the calendar of some other month and some other year, what you have to do, you have to type again the same command, calendar, and then in the brackets you can write for example, I want to see the calendar of October 2010. So 2010, and then comma, and then October is, I believe, 10th month of the year. So this will give me the calendar for October 2010. Okay, similarly you can find out this calendar of any time you want. Now date is basically going to show me the date, today's date, in the character format. Okay, this is important. You can see that this is in the single quote, so this is in the character format. Okay, over here you can also see that this answer is basically stored in the character format. Okay, So these are some predefined variables which you should avoid assigning values to. Okay. Now assigning the value in MATLAB is easy, as I've already told you. This is the MATLAB prompt which you have already seen over here. This is the MATLAB prompt, and then the name of the variable. Okay. Now by now you know the laws which is to be followed in order to define the name of a variable. Then equal to is basically your assign operator. Then 12 is the assigned value, and then the semicolon. This is just to suppress the command output. Now, comment operator is same as it is there in C or C++. It is after this comment operator, whatever you are going to write is just for you to tell basically is just for you to identify that what this command is doing. MATLAB will not read anything after this. Okay, MATLAB will not read any command after this comment operator sign. Okay, so this is how you are going to assign the values to any variable. Now moving further, there are some commands for managing variable, which I believe I have already told you that clear or clear all command removes all the variable from the MATLAB memory. If you want to delete some specific variables, you have to use clear, then the name of the variable. For example, you have n number of variables in the MATLAB memory, and you want to delete only x, y, and z variables. So what you have to do, you have to write clear x, comma y, comma z, and it will only clear x, y, and z variables. Now, who and whose are two other commands. Who basically list all the variables currently in the workspace, and whose list all the variables currently in the workspace along with other information such as size, class, and memory type. Okay. So for example, if I'm going to write who here, WHO. So it is going to list all the variables which are answer, X, Y, and Z. Over here, you can see that these are the only variables which are currently stored in the MATLAB memory. Now, if I want to get the information about these variables, I have to type WHO and then S after that, whose. So, sorry. Yeah. So whose is going to give me the name of all the variables which are stored in the MATLAB memory, the size of each variable, okay, and then the bytes which it is taking to store these variables, and the class of the variables. Okay, so as I told you that I've used this date command over here. Okay, so as I told you that it is the output of this date command is in the form of character. Okay, so you can see that here it is a character. Z was again a character where I've entered Khan, and then X and Y, the values of X and Y are 50 and infinite, so that's why they are double type of variables. Okay, so these are some variables, sorry, these are some commands which you can use to manage your variables. Now there are some other commands also just to change the output. Basically, so just to change the display format, not the output, the display format. For example, by default, okay, let's move on to this MATLAB again. For example, if I'm going to compute 22 by 7, okay, so you can see that although the value of 22 by 7 is n number of digits after decimal, but it is only showing me 4 digits after decimal. This is because by default, your MATLAB is format, basically the format of the MATLAB is such that it is only going to show you 4 decimals after, sorry, 4 digits after decimal. And this can be done with the use of this format short command. Okay, format short command. So format short command, what it will do, it will give you fixed points with 4 decimal digits. Format long will give you 14 points after decimal. Format short e will give you the answer in terms of exponent. Format long e will give you the answer in terms of again exponent, but there will be 15 digits after the, as you can see, there will be 15 digits after the decimal points. Now format short g, what it will do, it will take the best of fixed digit or the floating points, and it will only show you 5 digits in total. Okay, I'll show you over here. that, for example, I want to take format long. Okay, now the display format is format long. Now if I type 22/7, you can see that there are 14 digits after the decimal. Okay, similarly, if I'm going to change it to format short again, or format short G, it will again take 4 digits in total. Okay, sorry, 5 digits in total. So 22/7. Okay, you can see that there are 4 digits after the decimal and 1 before the decimal. So let's make it format short back again, because that's the default display format for the MATLAB. And there is again a useful command, which is format bank. So what format bank does is it will only show 2 digits after the decimal place. So this is useful when we are going to write some research paper. So we usually show 2 digits data after decimal only. In general, maybe there are some cases where you have to show more digits after decimal. So this is useful when you only want to show 2 digits after decimal. So this is how you can format the display output. Okay. Now this is your round off function. Now round off function, what does is that it let me go back to this thing again. Now suppose I have a y equal to 22/7. Okay, now I want to round it off. So what I can do, I can use round command, and then in brackets I can use the variable which is y, because the value of this 3.1429 is stored in a variable y. So when I enter this value will be rounded off. Similarly, if it is 3.7, okay, now if I try to round it off, it must give me an answer 4. Let's see what it is going to give. Okay, it is showing me 4, because what is happening is that this round command is rounding off this number, which is 3.7. Now similarly, you can use this command. Basically the capabilities of this commands are more. For example, you have a number 123.3456. Okay, this is a number which is stored in the variable a. Okay, now what you can do, you can use this round command again, and then with a comma you can give a number, for example 2. So what is happening is that, first of all, let's see the output of this command. So what is happening is that I have rounded off a variable a, and then after comma I have given a number which is 2. So what is going to happen is that if n is positive, what is happening is that after 2 digits, sorry, two digits after decimal, it is going to round off. Okay. Similarly, if my n is negative, for example -2, it is going to round off two digits to the left of the decimal. Okay, so I hope this thing is clear. If n is positive, it is going to round off 2 digits sorry, towards the right of the decimal, and if n is negative, it is going to round off n digits towards the left of the decimal. And if n is 0, for example, n is 0, okay, so n0 is same as round and without any thing. I mean, command is same as this command. Okay, it is going to give you 123, and similarly, without any number after the variable, you are also going to get the same output. So if your n is greater than 0, it is the command is going to round off the numbers or towards the right, n numbers towards the right of the decimal. And if your n is negative, then it is going to round off the number n digits towards the left of decimal. I hope this round off command is clear to you. Now the second command is fix command, which I have already shown you with the clock thing. So what fix command does is that it basically rounds each element of x to the nearest integer towards 0. Okay, so before taking fix command, let's see what seal and floor command does. What seal and floor command does. So seal command is basically it basically rounds each element of x to the nearest integer greater than or equal to the element. Okay, now for example, if you are going to use this round command for 3.14, it is going to show you the answer as 3 because that's how the round of thing works in mathematics. But if you are going to use the seal command, okay, for the same number 3.14, okay, for the 3.14 seal command will show you an answer 4 because what seal command is doing, it is basically rounding off the number towards positive infinity, or it is rounding off the number towards the nearest integer greater than or equal to the number. Okay, let me show you this on the MATLAB. First of all, let me clear the command window. Yeah, so suppose I have a variable a again equal to 3.14. Okay, now if I'm going to use a round command, it should show me an answer equal to 3. But if I'm going to use a seal command, it should show me an answer equal to 4. Yeah, you can see that it is showing me an answer 4 because what seal command does is that it rounds off the number to the nearest integer greater than or equal to the number. Okay, greater than or equal to this number. So if I have 3 itself, then it will show me an answer 3. But if I have anything greater than 3, it will always show me 4. Okay. Now, similarly, what floor command does, floor command is opposite of the seal command. Floor command rounds off each element of floor commands basically round off the number to the nearest integer less than or equal to the element itself, or in the other words, I can say that it rounds off to the negative infinity. Okay, so let me try this command, floor. Okay, now again with the same number a. Now, as per my understanding, it should give me an answer 3. Okay, it should give me an answer 3. Yeah, you can see that it is showing me 3. That is because floor command is actually rounding off the number towards the negative infinity. Now let's talk about the fix command. Fix command, as I already told you, it rounds off each element of x to the nearest integer towards 0. Towards 0. So if you can imagine a number line, so if you take any number, it will be rounded off to the nearest integer so that you are moving towards 0. So actually what fix command is doing, it is acting as a floor command for the positive integers and seal command for the negative integers. Let me show you this. If I use fix for the the same variable a, again it should give me an answer 3. It should give me an answer 3. Yeah, because fix command is behaving as a floor command for the positive integers, and it is behaving as a seal command for the negative integers. So these are some commands which you can, there is another command, remainder, which will basically give you the remainder when this x is divided by y. Another command is sign command, which will return a value of 1 if x is greater than 0, return a value of -1 if x is less than 0, and return a value of 0 if x is equal to 0. You can see over here that sign 7 is giving you 1. Had it been -7, then the answer would have been -1. Had it been 0, then the answer would have been equal to 0. So these are some commands which you can use to round off your functions or the variables. Okay. Now coming to the basic thing, which is a matrix, because this is important. So that this is how you are going to enter a matrix in the MATLAB. So A is equal to, first of all, the variable name, which is A in this case. Equal to is the assignment operator, and then the square bracket open, and at last the square bracket close. Within this, you have to write different numbers. For example, 1, 2, 3, and there is a space between 1 and 2 and a space between 2 and 3. If you don't want the space, you can use comma. So 1, 2, and 3 will basically give me the first row of this matrix A. And then I have placed a semicolon. So this semicolon is basically telling MATLAB that from now on, the row of this matrix A is going to change. Okay, so in the next row, 4, 5, 6, and again a semicolon. This is going to tell MATLAB that the row is again going to change, and that will be the third row, that is 7, 8, and 9. Let me show you this on MATLAB. For example, A equal to square bracket open, and then 1. I can put a space bar, or I can put a comma after that in order to separate two different columns. Okay, so let me put a comma for this. 1, 2, and 3. So this is telling MATLAB that 1 and 2 are two different two different elements of the first row of the matrix A. Then a semicolon. So semicolon is telling MATLAB that I'm going to enter into the next line, or in the next row. Then 4, 4, 5, 6, then 7, 8, 9. Okay, so here you can see that for the first row, I have used a comma in order to separate two elements, and for the other rows, I've just used a space bar in order to separate the elements. Okay, so those who have already worked with C or C++ will appreciate that how easily we can input the values of a matrix into a variable. Okay, because we have to write a command of basically a program of almost 9 to 15 line in order just to take the input from of for a matrix, and then to show the matrix, or to display the matrix on the screen. But for in case of MATLAB, we have just written a single line command. If I would have used a semicolon after the command, it wouldn't have shown me the output. Although this command has been executed, but it is not showing me the output just because I've placed a semicolon after that. Okay, now in order to know the size of any variable, it is not for the matrix or it is not for the number thing. In order to know the size of any variable, you can just use this command size, and then in the brackets you have to write the variable name. For example, A, it is 3 by 3 matrix. Now over here you can see that Z is a character type of a variable. We can also find out the size of this variable. It will be 1 by 4, because Khan is a 4 alphabet word. Okay, now again, this X is a single variable, which and a single value has been stored in this variable. It will also give the size of this variable, which will be 1 by 1. This is because, as I told you, all the information in the MATLAB is stored in terms of matrix. Okay, so I hope the assignment of a matrix is clear to you, how to enter a matrix, how to find out the size of any variables, and so on. This is just an example to show you. Now, as you add different variables, you can add your matrices also. For example, x plus y will give you the value of basically it will add the value of the variable x with y. Similarly, x minus y will how a new character is in an existing matrix. Okay, somebody is asking me how to enter a new element in an existing matrix. I'm going to cover that point also in the coming slides. Just wait for a second. First of all, let me tell you all these operations. Okay, so this is how you are going to add a matrix or subtract a matrix. Now, the next thing is the multiplication of a matrix. Now, over here, you can see that there is a dot and then multiplication sign and then y. So let me show you what it does is that let me make a matrix A equal to magic, and then B, another matrix B equal to B equal to 1, 2, 3. Okay, now if I'm going to multiply for example, C equal to A into B. So what it will do, it will multiply the matrix A with matrix B following the matrix multiplication rule. Okay, it will multiply matrix A with matrix B following the matrix multiplication rule. However, if I'm going to use C and then a dot and then multiplication sign and then B, what it will do, it will multiply the elements of matrix A with the elements, it will multiply matrix A with matrix B element by element. So for example, the first element of matrix A is 8 and the first element of matrix B is 1. So what the resultant matrix, the first element of resultant matrix will be 8. Similarly, the second element is 1 and in B it is 2. So the second element of the resultant matrix with this command will be 2. Let's see. Okay, sorry, I have multiplied it with C. It should be, okay, yeah. So you can see that the first element is 8 and the second element is 2 and so on. So if I'm going to use a dot before the multiplication sign or before the division sign, then what it will do, it will perform that operation element by element. Okay, otherwise it will follow the matrix multiplication rule. And you can perform the right hand division also in the MATLAB. It is, for example, x dot right hand division y is same as y by x, or a right hand division by b is same as b by a. Okay. Now somebody was asking how to add. Okay, so first of all, see how to delete a row or column. Now this square bracket, which you can see over here, is basically denotes an empty array. Okay, so for example, you want to delete the first, you want to make 0 the first element of the A matrix. So it will be A 1 comma 1. This is telling MATLAB that we have to perform an operation on matrix A on the first row and on the first column. And the operation is that, yeah, okay, okay. So basically it cannot basically it cannot make basically actually this thing is deleting the elements, so it cannot delete a single element. It has to be it has to be a complete row or a complete column. So in order to delete a complete column, what we have to do, first row, and this basically colon is showing you that all the columns has to be considered. Okay, and it should be equal to this null operator. Okay, so now you can see that previously your A matrix was 3 by 3 size. Now over here it is 2 by 3 size. Okay, now similarly you can delete a row also. For in order to delete a row, what you have to do, you have to use colon. This colon is telling MATLAB that you have to delete all the elements of the row of the first column. And it should be equal to the null operator. Okay, I have used 2 times this thing. What mistake have I made? Incorrect use of. Okay. Yeah, this red thing is written because this error is because I have used this command where I have used 2 square starting brackets. So that's why this error is showing. Otherwise, it wouldn't have shown any error. So anyways, now with the help of this command, you can see that the first column of this A matrix has been deleted. So the idea is, if you are using a colon in the first place, then basically in order to tell the MATLAB that the first indices of any matrix is your row and the second one is column. So if you are using a colon over here, that means it is telling the MATLAB that all the rows has to be considered. And if you are using the colon in the second indices, then it is telling the MATLAB that all the columns has to be considered. Okay, so if I am going to use a 2 comma 3, which it will not show me because this is only a 2 by 2 matrix, 2 by 2. So it will show me the 2 by 2 element of the, sorry, the second row and the second column element of the matrix A, which is equal to 2. So the first, it will be more clear if I use 1 by 2, sorry, 1 comma 2. So 1 comma 2 means that first row and second column, which is this element 7. So the first indices of any matrix is going to represent the number of rows or the rows, and the second indices is going to show the column. So this is how you are going to delete any column or delete any row in the matrix. Okay. Now adding a row or a column. Okay. So again, over here you can see that I have a matrix A equal, whose value is 1, 2, 3, and 4, 5, 6, which is my default matrix. And then in the second line, I have written B equal to A. And then this first, in the first indices within the square brackets, I have written 2, comma 3, comma 2, comma 3. And then in the second indices, I have written colon. So this colon is telling me that you have to store all the columns of A in the variable B. Okay, this colon is telling MATLAB that you have to store all the columns of matrix A into matrix B, and you have to use only you have to make 4 rows, and that rows are the second row, the first row of matrix B should be second row of matrix A, and the second row of matrix B should be the third row of matrix A, and the third row of matrix B should be the second row of matrix A, and so on. So that's how you can add a number of rows and number of columns in the matrix using MATLAB. Similarly, over here, what is being done is that you are basically storing you are going to make a new matrix C in which you are going to store the values from matrix A, where all the rows is to be stored. All the rows. Okay, you can see that all the rows has been stored, but you have added a column. Okay, you have added a column, the first, second, third, and again the third column is repeated. Okay, let me show you this again on the MATLAB. If A is equal to 1, 2, 3, then comma 4, 5, 6, sorry, comma, not comma, but semicolon, and then 7, 8, and 9. Okay, so this is a matrix A, whose values is 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now I suppose I want a matrix B from a new matrix B in which I want to copy the values of A. So what I will do, I have to copy all the rows, and then the first column of the matrix A and the third column of the matrix A. Okay. So over here, you can see that I have copied all the rows. This first indices is telling, since I have used a colon in the first indices, so it is telling MATLAB that I have copied all the rows. So that's why 147, all the rows are copied. And only the first and the third column has to be copied in matrix B. Similarly, you can copy all the columns also. For example, C equal to, again, matrix A. And then I have to copy, suppose, second and third row. Okay, I have to copy second and third row and all the columns of matrix A. So you can see all the 3 columns, because originally matrix A is having 3 columns. All the 3 columns has been copied, and the first row is been deleted because I have only copied second and third row. Similarly, you can copy, basically you can combine B and C, but since the dimensions of B and C are not same, so first of all, I have to use this command C equal to C prime. What it will do, it is going to basically take the transpose of C. Okay, the C prime is going to take the transpose of C. Now what I can do, I can make a new matrix D, which will be equal to B and then colon C. Okay, let me see what is the problem. Okay. Because yeah, I have to use a comma. Invalid when calling a function and receive parentheses. Okay. This is happening just because the what what I should say, that this is happening because the size of the matrix B and C are not in accordance with the matrix rule. But anyways, you can make a new matrix, for example, D equal to B. Yeah. So what it has done is that it has combined the matrix B and C with C in the new column. Okay. So anyways, this is how you can manipulate your matrix. You can add or delete or add the informations in the rows and columns or in the
Initial value you are giving in the curly you can't upload. Then I said,
now
okay,
there are some
you send it by mail.
somebody wants to ask any question. Yuvraj? Yuvraj? Okay, no problem. Nobody's asking any question. Now these are some, I'll just hurry up because the time is running. So these are some of the commands which is very useful. The first one is x equal to start and then colon and then end. What it will do, it will, okay, let me show you directly on the MATLAB. X equal to 1 and colon and 10. So what it will do, it will make a vector or make an array starting from value 1 and ending at value 10 with an increment of 1. Okay, with an increment of 1. Okay, so you can see over here that what this command has done, it has started, it has made an array starting with the value 1 and ending at 10 with an increment 10. Now suppose you want your user defined increment, so what you can do, you can again use the same command, but at the center what you can do, you can specify the increment size. For example, in this case it is 0.5. Okay, so now you can see that instead of 10 elements, there are 20 because it is with an increment of 0.5. Similarly, if you suppose you have some numbers, say 1 and 10, and let me show you the syntax of, sorry. Let me show you the syntax of this. Suppose you have some number, starting number and ending numbers, and you know the number of divisions which you want. Okay, you don't know the increment size, but you want to know, but you know what is the number of divisions which you want to, number of elements which you want. So what you can do, you can take 1, 10, and suppose I want 20 elements. Okay, 20 or maybe 25 elements. Okay, so it will give me 25 elements starting from 1, ending at 10, and the increment size has been decided by the MATLAB, and I don't need to decide the increment size. So if the increment size, if you already know the increment size, you can use this command. Otherwise, you can use this linspace command, wherein you have to enter the first element and the last element, and then the increment, the number of elements which you want. Now the next one is length x. It will return the same as size. It will return the length of the vector x. Y equal to x prime will give you the transpose of the matrix y, the matrix x, and it will be stored in y. Dot x comma y will give you the dot product of matrix x and matrix y. Okay. Now there are some matrices operations which, for example, if you want an identity matrix, so you can use this command I and then in the bracket n. So it will return you an identity matrix of size n by n. And if you want some, suppose if you want an identity matrix with different number of rows and different number of columns, so you can use this I m comma n, where it will return you identity matrix of number of rows equal to m and number of columns equal to n. Now matrix multiplication, I have already told you, you can make an inverse of any matrix using this command inv. You can find out the rank of any command using the command rank rank. And the determinant is basically calculated with the help of det, comma a. And is prime is just to check whether the number a is a prime number or not. If it is returning you a value equal to 1, that means it is a prime number. If it is returning you a value equal to 0, that means it is not a prime number. For example, if I am going to type is prime and then in bracket 7, so it should return me a value 1. And if I'm going to use the same command, and if I'm going to use suppose 2 or maybe 6, which is not a prime number, so it will give me a answer equal to 0, which is telling me that 6 is not a prime number. And these commands can also be used on the matrix. For example, I'm going to use this command on a matrix A. So this is showing me that the first element of matrix A is not a prime number. The second element is a prime number. The third element is a prime number. The fourth element is not a prime number, and so on. Okay. And if you want an identity matrix I equal to 5, this will give me a 5 by 5 identity matrix, a square identity matrix. And I 2 by 3 will give me an identity matrix of size 2 comma 3. Okay, anyways, there is another command which is magic 3 will give me a square matrix of size 3 where the sum of all the rows and all the columns will be same. For example, if you are going to sum this 8 3 and 4, it will be equal to 15. Similarly, if you are going to sum this 8 6 and 1, it is again going to be 15, and so on. All the sum of all the rows and sum of all the columns will be same. And another, if you want to generate any random matrix, so what you can do, you can use RAND command and then 3, which will give me a random matrix of size 3 by 3. Okay. And then again, all the round off commands can be used for this matrix as well. Okay, you can see that it will not only round off any number, but it can also round off any matrix also. And all the commands which I've told you are valid for a single value variable, as well as for the matrix of any size. Okay, now moving on to the next slide. These things I have already told you. I hope these are clear because these are simple addition and subtraction, multiplication and transpose. This thing I have already shown you. This command, what it is doing, it is starting it is making an array where the number are starting from 1 and ending at 10 with an increment of 1. And over here you have given a user defined increment. Okay. Now, yeah, you can also get an matrix with all the values equal to 0. For example, I'll show you zeros with the help of this command zeros and then 3. So it will give me a matrix of 3 by 3 with all the values 0. This is useful when I have to store some values, and the size. For example, I have to find out some deflection at different points. So the size of the matrix is already known. Or for example, if I take a stiffness matrix, okay. So I don't know the values of a stiffness matrix that MATLAB will calculate depending upon my code, but I need a matrix of size 3 by 3 where I can store these values. So first of all, in order to define that matrix, what I will do, I will say y equal to zeros and then 3. So this will give me a 3 by 3 matrix with the value 0. And then later on in my code, I can input or insert the values in this matrix. Okay. And similarly, if I want a matrix with the values ones, I can use ones command, and random I have already told you. Okay, now the matrix indices cannot be negative. Okay, it cannot be negative, and it cannot over exceed the already existing indices. For example, this is a 3 by 3 matrix, and if you are going to find a value of a minus 2, it will not give you because it cannot be negative. Okay, or it cannot even be 0. Those who work with C and C++ should be very careful, because in that language the indices of a matrix start with 0, but in MATLAB it starts with 1. Okay, and as you can see that A is a 3 by 3 matrix, so you cannot get a value of A 4 comma 3 because there is no fourth row in the matrix A. Okay. Now these are the operators which you can use. Power is to use raised to the power anything, for example, and you can use all these operators on a single value variable as well as on the matrices. Obviously, you cannot multiply two matrix if it is not following the matrix multiplication rule. But you can use the dot and then multiplication thing if you want to multiply two matrix element by element. As you can see over here, dot star will multiply matrix A with matrix B element by element, and so it will divide, and so it will raise to the power element by element. Okay, now this is just an example. I have already shown you how to display all the rows, sorry, all the columns and the first row, how to display the third row and all the column. Okay, the time is running out. I'll try to conclude. Dr. Danish, I'll try to conclude within 10 minutes. No worries, okay?
Okay, sir. Thank you.
Okay, so now this is how you are going to solve the system of linear equation. Over here, you have three linear equations. This is the first purpose why MATLAB was invented. So what we have done, we have stored the values of basically the coefficients of the x1, x2, and x3 in the matrix A. And then we have stored the variables x1, x2, x3 in X, and then all the constant values in matrix B. So mathematically, A into X will be equal to B, and we have to find out the value of X, so it will be equal to B into A inverse. Okay, so this is very simple. You can try, and if you have any problem, you can always contact me. Meanwhile, if you have MATLAB on your system, you can try this. Okay, I would have shown this, but since the time is already passing and only 10 minutes are required, and I don't need to show you how to develop a user-defined function. That is very important. Now, can we get the PPT post? Yes, obviously you can get the PPT. I'll share it with the organizers, and they will share it with you. Okay. Now, this is the syntax for the integration. From now on, what I will do, I will just show you the syntax because I have to conclude now. So for order to find out the value of an indefinite integral, okay, but let me go back to this MATLAB once again. Now, suppose I have to use a variable with a name VA with a name variable itself. So since till now there isn't any variable stored with this name, so MATLAB must give me an error. Okay, so what MATLAB is saying that this is unrecognized function or variable. But what I can do, I can use this sims command. Okay, this is a very important command of MATLAB, sims variable. Okay, now MATLAB knows that there is a variable stored with the name variable whose value has not been assigned. Okay, this is purely variable whose value we don't know. So what we can do, we can make a function y equal to variable variable to the power 3 plus variable to the power 2. Okay, now I have a function. Now suppose I want to differentiate this function. So what I will use differentiate command, and then I can use this function name. Basically, the value of this function has been stored in y, and then I can simply differentiate this because this is a single variable equation, so I can simply differentiate it like this. Had it been a two variable function, then I would have to mention the variable name respect to which I want to differentiate. For example, there are two variables. These variables are different, variable 1 and variable 2. So at that time, I have to specify the variable name respect to which I want the differentiation. Okay. Now this is a single differentiation of this function y. Now suppose I want to differentiate it twice. So what I will have to do, I have to write 2 over here. Okay, now you can see that it has been differentiated twice. This is the first differentiation, and then 3 to the 6 variable plus 2. So this has been differentiated twice. Similarly, if you want to differentiate some equation n number of times, so you can use the variable n over here. Whichever number of times you want to differentiate, you can use it over here, and it will be differentiated in a single command. Similarly, you can integrate of indefinite integral. Since it is indefinite, so you have to use the sims command again. And the syntax for that is integrate the function. For example, in our case, it was y, and then the variable name. Let's do this also. Integrate the name of the function y, and then the variable, which is variable. Okay, so this is giving me an indefinite integral of the function y. Similarly, what we can do, we can also find out definite integral where after the function name, after the function and the variable, we have to specify the lower limit and the upper limit. I hope this is simple and you can do it on your own. Now, this is for the differentiation, which I have already shown you. For a single differentiation, you need to, for a multivariable differentiation function, you need to specify the variable. For a single variable function, you need not to specify the variable. And if you want to differentiate it more than once, then you need to specify the number of times you want to differentiate that equation. Now, this visualization part I'll skip because it will. I hope this will be covered by Dr. Asfar in the coming lectures. I just want to discuss some things, but since the time is not permitting, so I'll just hop on to the user-defined functions. Okay. But before that, I have to tell you how to make an M file. So over here, you can see this new script. So if I click on this new script, I can make my own functions. Okay. For example, I can write anything. Okay. I am just writing rubbish, but just to show you that how to save an M file. So what you can do now, you can save this file over here. Okay. So it will be saved with the name untitled2 and with the extension .m. Okay. Now you can share this file with anyone. You can run this file on any computer, or you can run this file on an online platform, which will again be discussed by in the coming lectures. I've seen the schedule for this FDP. So the idea is that now you have this code with you. You can use it anywhere. You can integrate this code with Abacus. You can integrate with this code with the answers, or you can do whatever you want. You can share it with anyone you like. Okay. Now, the other important thing is your user-defined function. So I have this user-defined function by the name. Let me check this first. Yeah. I have this user-defined function with this name cube.m. So someone is asking for the visualization part. Actually, I'm sorry for that because I have only 2 minutes left in this lecture, so I have to rush it too. But what I can do, I have a YouTube channel. I will upload it on the visualization part as well on my YouTube channel, and I'll share it with the organizers. You can basically see my lectures over there. Okay, I'm sorry again for that because the time is very less. Anyways, coming back to this function. So this function is basically with the name cube. Okay, and this is the output variable n3, and this is the input variable. So what I can do, the name of this function is cube. Okay, the name of this function is cube, and in brackets, I have, for example, this value 5. So what it will do, it will give me the cube of this function. However, there is a predefined function already existing in the MATLAB for cube, but just in order to show you, I have used this thing. So what it is doing, it is telling MATLAB that you have to call this function with the name cube, and you have to give this input value equal to 5. So what is happening is that this function has inside the function, this function is basically taking the cube of the number n, and then this function is basically returning the value in this square bracket. So whatever I'll write after function in the square bracket, that will be an output argument, and whatever I will write this the variables inside this close bracket after the name of the function, that will be the input variables. So that's how you can define the functions. And if you have any questions, I'll share my PPT with the organizers, and I'll share my email ID also, so you can always contact me. I'll love to answer your questions. So thank you all the participants for listening my lectures patiently. And